Hello. In this video, we are going to learn about the formula node. Now, the formula node is a resizable box that you can use to enter an algebraic formula directly into the block diagram. Now, this feature is extremely useful when the function equation has many variables or is otherwise complicated. For example, consider the equation y is equals to x squared plus x plus 1. If you try to implement this equation using the arithmetic function, it looks something like this, and there are a lot of chances of creating errors. So LabVIEW has this feature of formula node that you can go to the functions palette, and then from the structures you select the formula node. So here's how the formula node looks like, and then you can right click and add the input variable, and then similarly the output variable, and you're supposed to even add any kind of intermediate or dummy variables too. You can also perform some the conditional branching inside a formula node, like if else statements. So I'm going to demonstrate the exercise 6.4, the formula node exercise VI. So the objective here is to use the formula node, and you will build a VI that uses the formula node to evaluate a complex mathematical expression and graph the results. So let's get started with it. I'm gonna build the front panel. So on the front panel, we are just going to have a waveform graph. Moving on to have a formula node now. Okay, so this is my formula node, and then we can write the equation here. Tan h of x plus cos of x followed by y equals a to the power. So when you want to write to the raised power, so you have to put just double asterisk plus a. Okay, so we have entered the equation here. Then we right click and say add input. And then we are going to have add output. Add output, because we have like an intermediate output, which is a. So this is I'm going to enter this as x. Here you need to type in Y, here A. Okay, so now we have to set some X values. So what we can do is we can have a for loop that performs iterations. We have to somehow connect this. So the I values, we have to give a range of X values. So one way you can do is you can utilize the iteration number. So just gonna take this and divide it by 15. And I'm gonna create a constant. And now we have set the range of values for X. Okay. We need to set the number of iteration constant 200 iterations. And then we have to display the Y values. So we are going to connect this to the Y. Oh, yeah. So it doesn't take like scale. It cannot plot scalar values, the waveform graph. It has to be outside the loop. It just accepts arrays. And then let's turn on to indexing. So these scalar values will auto index. It will form an array, 1D array, and that will be plotted on our graph. So let's see, let's run this code. Okay, it's showing me some kind of error here. Let's see. Missing semicolon. Yes, of course, we shouldn't forget that always these equations have to be terminated with semicolon. Okay. Okay, now I have no errors. Now we can run this. Okay, so we get this output. So this is very easy implementation of algebraic equations in LabVIEW using formula nodes.